Hello everyone, this video is different from my other videos. In this one, I will provide a beginner's guide to SolidWorks and show you how to create sketches. Let's get started. When you start SolidWorks for the first time, you will see something like this. In top left corner, you will see option to create a new document and open an existing document. When opening a new document for the first time, it will ask you to set standard units and dimension. Select the one which you will be using most, then click OK. Now you will see these three options: Part, Assembly and Drawing. In Part, we create machine parts which can be further joined in assembly to make a complete working machine like a piston, engine, etc. And Drawing is 2D representation of a part or machine. For now, we will select Part. Here, the top area is known as command bar, where we will find all the commands which will be used to create model. The middle area is known as canvas, where we will see the model which we have created. In the bottom left of canvas, you will see three axes. The remaining left area is known as design tree, which shows all the features and sketches used to create the model. You can change the units of a sketch from bottom right corner, and you can also make your own custom units. Let's take a look at an example. While using CAD software, it is necessary to have a mouse. By scrolling mouse wheel, you can zoom in and zoom out. You can select any part using left click and see its settings using right click. By clicking mouse wheel button, you can rotate the model. You can move the model up, down or right left by pressing Ctrl plus mouse wheel button. Since we have a model, so you can see its features in design tree. You can also see some basic view options above model like view orientation and display style. These allow you to see the model in different views. Now to start sketching, first we have to select a plane. You can start with any plane as you see fit. To start sketching in a plane, click on Sketch, then Sketch. Or alternatively, just click on Plane, then Sketch. The red arrows in center shows origin. The right arrow represents x-axis while left arrow represents y-axis, and their intersection is origin. We can use commands to make any shape. Let's discuss them one by one. First, we have line command, which, as the name suggests, is used to draw lines. When the line is horizontal or vertical, you will see this symbol, which tells us that the line is straight. There is also this symbol which shows that the lines intersect here. To unselect any command, press escape. Next command is rectangle, which is used to make rectangles or square. You will notice that our cursor changes with command, which is helpful in identifying the command which we have currently selected. You can create rectangle using different methods based on requirement. These are corner rectangle, center rectangle, 3-point corner, 3-point center and parallelogram. To remove a sketch, select the sketch, or to select all, press Ctrl plus A, then press delete. Next command is circle, which can also be created using two methods. One is radius and other is perimeter. Then we have arc, which can be created by center point, tangent and 3-point. After that, we have polygon. We can adjust its parameters based on our need. These are all the commands which are majorly used to create sketches. There are also other commands like straight slot, spline, ellipse and sketch fillet. You can explore them while practicing. Now let's talk about dimensions. I created a shape and wants to change its dimension. There are two ways of doing that. One is to select a smart dimension option, then select the side or entity and change its dimension. Other is by changing its parameters from design tree. You can use either of them, but smart dimensioning is preferred as it makes it easy to know the dimensions of an object. Similarly, you can also use it to dimension diameter, angle or anything else. To dimension angle, select any two lines. Sometime you will see this option. Dimension driven means that this dimension is dependent on other dimension. In this case, you have two choices. Either let it be driven or make it driving. Driving means you can change its dimension. I will select driven and as you can see, I am no longer able to change its dimension and the driven dimension is represented in grey color. Similarly, if you define two angles of a triangle, then other angle is automatically driven, so you won't be able to change that. Now let's talk about relations, which are very important. I made these two lines and by selecting it, I can add relation from design tree. I fixed the right side line, which means I can't move it. I can also make it horizontal or vertical, but I cannot select both. Each relation is represented by its symbol. To remove a relation, click on the relation and press delete. You can also set relation between 2 points or entities, like making them horizontal, vertical, coincident, fix, or merge. When selecting lines, you will see more options like perpendicular, collinear, and equal. You can set relations with any entity. In case of circles, you can make them co-radial, tangent, concentric, equal, fix, and equal curve length. Now, to show you the power of relations, here is an example. You will see that all the shapes and lines in this sketch are in black. This means that the shape is completely defined and you cannot change any of its dimension. Let's remove this equal and vertical relation. Now, when we move the line, see how the complete sketch changes according to relations. Using relations reduces mistakes while creating a large sketch. At last, let's talk about some special sketch commands. First is mirror entities. This command mirrors the object with respect to selected line. Select the entities to mirror and mirror about, then press enter. This is very helpful while making a symmetrical object. Next, we have offset entities. Select the entity and specify offset distance, then hit enter. It will make its copy at that distance. We also have trim entities command, which trims the object. Click and hold the left mouse button, then move it through the part which you want to remove. The main difference between trim and delete is that trim will delete the entity till any intersection, while delete will remove the complete entity. Last one is linear sketch pattern. It makes the copy of selected entity at a given distance. You can adjust the spacing and number of objects, then select the entity. First, we will create a new part document and then make a square. Converting a 2D sketch into a 3D model is pretty easy. Just click on the Features tab and then select the Extruded Boss Base feature. Now you will see a preview of the model. We can change it according to our design. A cube will be good. Now we have 6 new planes and we can sketch on any of them. To sketch on a plane, just select the plane and sketch. Let's make a square in its center. Mine is already in the center, but if yours is not in the center, then use relations. Now we will use the extruded cut feature, which will make a cut in the model. We can also change its distance or up to the next vertex, plane, etc. The next feature is fillet, which curves the edges. Select the edge, then fillet type, constant size, variable size, face, or full rounded fillet. You can also select all the edges by selecting the plane, then done. Let's remove the fillet for now. Below the fillet, you will see the chamfer feature, which converts the edges into slopes. Select the edge and type angle distance, distance, vertex, offset face, or face. Similarly, you can select all the edges by selecting the plane. Mostly, angle distance and distance chamfer are used. In design tree, you will see the material, which is not specified. From here, you can select the material of your model, or you can also create your custom material. You will see the properties of that material like elastic modulus, Poisson's ratio, tensile strength, etc. And you can also change the units. After applying the material, your model will change. Now you can see its properties by selecting mass properties in the Evaluate tab. Here you will find mass, density, volume, center of mass, and many more properties of the model. These properties change based on the material. Let's talk a little more about the design tree. We can see the original sketch by clicking on this symbol. We can also edit the sketch by clicking on Edit Sketch. Let's increase the side length to 120. Then exit the sketch. And now our model is also modified based on the sketch. This line is used to roll features. You can use it to see how a model is created. You can also hide a feature by right-clicking and selecting Hide. You can also see parent-child relationships by right-clicking on a feature. Parents are the entities used to create the feature, like how we made boss extrude using sketch 1, the top plane and the origin. Children are the entities created using the feature, like sketch 2, cut extrude and chamfer. Now let's explore some more complex features. I will create a random model to explain upcoming features. I created a rectangle on this plane of the model and want to extrude it until the curve in front. Select the extruded boss base feature, and to make the curve, we will use AND conditions. When we increase the length, the shape goes through the curve. We will use up to next, and now it is curved. These conditions are very handy when making complex models. The next feature is resolved boss base. I created a semicircle, and by selecting an axis of revolution, which in my case is its diameter, this automatically creates a sphere of that radius. You can also change the AND conditions of the angle. By using a rectangular plane, I can create a cylinder. The opposite of revolved boss base is a revolved cut, which cuts the material about an axis of revolution. For the cylinder, I will select the front plane and draw a square. Let's move it to the midpoint of the side line. Now, we will make its axis of revolution using a construction line. Then use the revolved cut feature. The next feature is swept boss base, for which I made two sketches in two different planes. One is the U shape, which will be the path, and the other is an ellipse, which will be our sketch profile. Select the feature, then select the profile and path. As you can see, it made the sketch profile shape on the path. I should have placed the ellipse at the corner, but no worries, I can simply extrude it, and this will be the shape when you place the ellipse on the corner. The opposite of swept boss base is swept cut. To show this, I will sketch a circle on the plane of the ellipse. Now select the feature, then select the circle as profile and the U shape as path. If you don't see the previous sketch, right click on it and select show. As you can see, our model now has a circular cavity through the path. The next command is reference geometry, which is used to create planes, axes, coordinate systems, points, center of mass, bounding boxes, and mate references. The most useful feature is the reference plane. Suppose I want to create a cuboidal cavity on top of this model, but there is no plane there. In that case, I will use this feature to create a plane. To make a plane, I have to select references. Let's select this surface and the curved surface. It has created a new plane perpendicular to the surface. To shift it on top, I will select parallel. You will also see a message that our plane is fully defined. Now, let's sketch a rectangle, then extrude cut, and see that our cuboidal cavity is created. There are 7 ways of creating a reference plane: 3 points, a line and a point, 2 lines, other planes, a plane and a line, a plane and a point, and a plane and a curve. The next feature is a bit complex, so I have made 4 different sketches in 4 different planes. Select the lofted boss base feature, then select all these shapes as profiles, and you are done. It will create a 3D model based on those profiles. Now, to guide the model, we will select the top plane. Let's hide all these planes and create random lines to connect each shape. These may look connected, but they are not. Select the point and shape, then select piers to connect them. Let's mirror these lines and also pierce them. Now, while using lofted boss base feature, select those lines as guided curves and see how the model changes based on these lines. The opposite of lofted boss base feature is lofted cut. To show it, let's create a circle on the circular plane and a pentagon on the pentagon plane. Now select the feature, then select the profile, and you are done. This will create a cavity like this. You can also use guided lines for this as well. And this is what its cross section will look like. There are two ways to make an assembly. First one is by directly opening new assembly file and add parts. Other is to create an assembly from part. I made this part, and now to create an assembly, click on arrow near new document icon, then select make assembly from part or assembly. In assembly, we assemble different part or assembly to create a machine or any product. I have inserted these two parts. You can add multiple parts using insert components option. The first inserted part in an assembly is always fixed, which is denoted by F in the design tree, while we can move every other part, which is denoted by minus sign in the design tree. Now let's assemble or join different parts. I have inserted these 4 parts, and to join them, we use mate feature. Just select the dimension and set mate, which are similar to relations. I made the upper face of block and cuboid coincident, that is, in same plane. Usually, Solidworks automatically identifies the condition and set mate. Mate is of different types: standard, advanced, analysis, and mechanical. But I will be covering the standard mates as these are commonly used. You will see that cuboid is still moving, but in same plane, and to fix it inside that cavity, we have to use more mates. First, let's make the vertices coincident. It is still movable, so we will coincident another vertex, and now our cuboid is fixed. You will also notice that the minus symbol in front of cuboid is also gone, which means that its position is fully defined. There is a move component feature which is used to move parts, and below it there is rotate component which is used to rotate parts. Similarly, let's fix the other two shapes and it's done. For next example, I inserted a block and a cylinder, but I need 3 cylinders. There is a very useful shortcut in SolidWorks to copy parts. Press and hold Ctrl key, then drag the part. A copy of that part will be automatically created. Now let's fix the cylinder in block using previous mates. You will notice that we fixed its position, but it is still rotating. You can leave it at that if your final product has movable parts. Otherwise, there is a way to fix the rotation. Select one of the side of hexagonal cavity and any face of block, then make them parallel. Now the cylinder is fixed. Same mate on the other cylinder, then let's make it parallel to the right face and done. As for third cylinder, we will make it tangent to one side and coincident to top face, then we can rotate it on side like this. Now if you want to remove any mates, click on arrow near mates in the design tree, and here you will see all the mates. To remove a mate, select it and press delete, then yes. We can also remove a mate by right clicking on a part and select view mates option, then delete the mate. You can also hide and unhide mates by right clicking. Next, we will see angles and distance mate. I inserted a base and 4 wings. First, we will connect a wing to right side vertex, and as you can see, it only moves circular. To fix the angle, select the upper faces of both base and wing, then click on angle. Note that this angle is between 2 faces, and done. Similarly, set the other wing. Now we will set this wing straight on top. After setting up, this wing can move on the surface. To fix this at a certain distance, select the face and vertex, then set distance. This will fix the wing. You can also set distance between 2 faces. Now, final mate type, which is lock. Select any 2 parts and click on lock. This will lock the part with respect to other, and when you move one part, the other will also move with it. Just like in assembly, we can open SolidWorks drawing file in 2 ways. One is by directly opening new drawing file and selecting sheet size. You will see all these standard size. We can create our custom sheet size or uncheck this option to select any non-standard size. For now, I am selecting A2. Simply click on Browse and Left to insert any part or assembly. Alternatively, open any part or assembly and select Make Drawing from Part or Assembly option. Then select Sheet Size and Done. Now we can select the view and drag it to the sheet. I place the front view, and when I go up, it shows the top view, and when I go sideways, it shows the side view. These three views collectively is known as orthographic view, and when I go at 45-degree angle, it shows isometric view. Isometric view is very helpful as it shows the final entity. When we drag any orthographic view, other views move with it, except isometric view, which is independent. We can also add other view from here. You will notice that size of our drawing is small compared to the sheet. To change size of drawings, select any drawing and in design tree, select custom scale in scale. By changing scale, we can change the size of our drawings. Drawings are made to specify an entity in 2D. So now we will add dimensions, which is done by Smart Dimension option, just like we did while drawing sketches. From isometric view, we know that these three circles are holes, but without isometric view, we can't identify that. So to make it clearer, go in Annotation and select Hole Callout option. This shows that these are holes, not just circles. There are also many different options in annotation based on use case. We can use different drawing style by selecting the object, then selecting style in design tree. We can also change display style from design tree as well. At last, fill the drawing details in the box below. After completing the drawing, we have to export it. To save a SolidWorks file, simply click on Save on top or press Ctrl+S. And to export a SolidWorks file, click on Save As, and here in Save As type, we can select our desired export type like PDF, JPEG, PNG, etc. You can customize export from options, and after that, click on Save. Now I will show you how to create an air piston cylinder using the features. Our final product will look like this, and to create it, first we have to make these 11 parts. All the dimensions are in IPS and material is plain carbon steel. I will make a PDF of these parts and place it in video description. So let's get started. All parts are created, so now we will assemble them. These are the location of parts, so let's join them using simple mate features. Finally, our air piston cylinder is completed. Now, we can check its mass properties, assembly visualization, performance evaluation, costing, and many more things. This concludes my video, and if you have any problem, then comment me down below. See you in the next one.